Hello everybody and welcome back, and in this section right here we are going to take a look at the errors in Python 3. Now what I mean by errors is sometimes some error will occur in your code without you actually being able to know that in advance. Therefore, the last thing you actually want is your code to actually crash or your program to crash just because of that simple error. Therefore, we're going to learn right now how we can deal with errors, how we can actually assume some errors coming, and how we can use different syntax in Python 3 programs in order to actually avoid those errors and avoid our program crashing once some error occurs. So, for example, the most common error that you might have all known is the zero division error. What that error actually is, for example, we know that we can't really divide any number with a zero. Therefore, what happens if you actually try to divide a number with a zero in Python 3? Well, an error will occur. So let us open up your idle just to show you. So idle right here. And let's say we have a to be equals to 3, b equals to 0, and then you simply just type here a divided by b. You will have a traceback call to our third line, which will say zero division error division by 0. Now this will crash your program and it will not continue to execute if you have some other code after it. It will crash it and the program will no longer run. So right now let us see how we can actually deal with this. Now this is one of the errors. There are many other errors that can actually occur. For example, there is also an overflow error. It is raised when a calculation exceeds maximum limit for a numeric type. There is also an attribute error which can be raised in case of failure of the assert statement. So, first of all, what is an exception? Well, an exception is an event which occurs during the execution of a program that will disrupt the normal flow of program's instructions. So for example, let's say we have a program that performs this task right here, but the only exception for this task right here would be if b equals to 0. And in case b equals to 0, we want to perform a different part of a program rather than letting our program simply crash. So that is an exception. Now, in order to use the exceptions, we need to implement in our code the try and except rule. Now the try and except rule looks something like this. So this is the basic concept behind it. You have to specify try, then two dots, and once you tab something in, it will tab it by default in Python 3 idle. You do your operation right here. So some task is right here, such as for example this right here. We're going to take a look at a real example just after I specify you just right after I specify to you the actual usage, so some task, and then you have except as a word. So this is also a word in Python 3 that is already used. Once again, we get the update error. Never mind. Let's just close it. So except exception 1, we can use it like this. So this would be exception 1. For example, when b is equal to 0, you just type here, if there is an exception 1, then execute something else, different task. If, for example, b is equal to 0, you can also add multiple exceptions if you want to, but once you actually, but in our case, we only have one, and that is that b equals to 0. And basically, after it, you can simply specify else if you want to, which will basically, if there is no exception, it will execute this block right here. If there is no error, it will execute this. So the example, let's first of all take a look at the example of you dividing by 0, and then let's also take a look at a different error example by using a different error, which is going to be an error while opening and closing files that don't really exist. So first of all, let us write this same code, but right now let's try for our program not to crash. So try, and then a equals 3, b equals 0, and then c equals a divided, oops, where is the, okay, so here it is, print c, and then else, oops, not else, pardon me, we need to specify right here except, and then you need to specify the name of the error, so zero division error, except zero division error, print, and then we'll print to the screen, can't divide by 0. Okay, press right here, and you can see that this program simply prints out can't divide by 0. Okay, so our program didn't crash, we got a specific string printed out to the screen that will say can't divide by 0. If you actually used same code right here and actually specified something that is not equal to that is not equal to 0 right here, it will execute this task and it will print the result. So this is one of the examples of actually dealing with the zero division error. Now let's take a look at the example of dealing with the IO error, which is raised when an input or output operation fails, or basically such as trying to open a file that doesn't exist with the open function. So in order to check that one out, type here try. What we are going to try to is we're going to have our file descriptor right here. So let's call it fn as usual, equals open. And let's type some random name right here. We know that this file certainly doesn't exist in our directory. We want to open it for writing, okay? And then we want to actually write right here. Or pardon me, this will actually create a file. So let us just do it like this. Open it just like this. So what this will try to do is it will try to open a file that actually already should exist, but in our case it really won't. And then we will try to write to it, this is a test file, which is a string, and then we will accept an error, which is called IO error, which is the input-output error I was talking about. And then we will print, for example, can't open that file, it doesn't exist. Okay? And then we can simply just use the else that I showed you right here. It can be used if you want to. So else is not only used in the if-else statement, it can be used here as well in order to execute a code that will actually be executed whether no error occurs, which in our case will not be executed. So this print statement right here, everything worked well, will not be executed because we will actually run into the error. So press here enter, and you can see the only thing that gets printed out is can't open that file, it doesn't exist. This print statement doesn't get executed, and this file, this write statement or write function doesn't get executed as well because this file doesn't exist. We only run onto this error right here, which says can't open that file, it doesn't exist basically. Now, you might be asking, well, how I can actually know what the name of the error is in my code. Right here we saw that it is a zero division error. Right here I told you that this is an input-output error, but what, for example, if you don't really know what error you will receive, how you can deal with the errors themselves? Now, you can deal with them by using normal except statement right here without actually specifying any error. For example, you can write this same program right here just without specifying this part. It will actually perform the same task. But this is a bad practice. Well, this kind of try and accept statement catches all the exceptions that occurs, but it is not considered good programming because even though it will catch the error and your program will not crash, you will not exactly know what the problem was to your program. So it could be something that you might have missed that is actually important error that you need to fix sooner or later. And with the accept statement, you really won't know what the error was. Okay, so let us see, or let us take a look at that one as well. Simply we can write the same program right here. Let's write it right here. So fn or fd, let's call it like that, equals open non-existent file. Okay, and then, whoops, I'm missing try right here. We try to open this and then we try to actually write to that file some strings. For example, we want to write something like that, and we don't know right now what error we are going to run to, and therefore we are only going to specify except and then afterwards 2 dots, And this is going to be printed out for any error that occurs. So basically, if any error in all of the errors occurs right here, we will print file doesn't exist. But what the danger is because this might not even be the correct actual statement for this error. So it might actually not be the error that the file doesn't exist. It could be something completely different. And for that different thing, we're also going to print file doesn't exist, which might actually not be true. Okay, so that is the problem with the except, even though it will work. And then we can code else print everything worked fine. Now, in order to actually check out whether this else statement works as well, we're going to change our directory to the actual desktop directory, just so we can actually test it with a file that does exist. So os.change directory to my desktop. Okay, so we change the directory, we save this. Let me go to my Python programs, errors.py. Let's run it. And it says file doesn't exist. Okay. Now, let us actually create a non-existent file. Just by going here. Or let's actually create it in our code. We know how to do it right now. So fn open non-existent file, let's call it .txt for writing. And then we write this. Right now, it should work. And not only that should it work, first of all, let me delete the previous file. And not only that it should work, it should also print this statement right here, everything worked fine. So let's run it. It says everything worked fine. And if I go to my desktop right here, we should have a non-existent file.txt, which of course will not have anything in it because we didn't really close it. So let's close it right here. Save it once again, run it, everything worked fine, and right now we will have some strings written to a file. And this error will not occur at this specific time. Okay, so basically that would be about it for this introductory video for errors. We're going to take a look at some different examples in the next video, so hope you enjoyed this lecture, and I hope I see you in the next one. Bye!